Okay, this is section 6.2, Properties of Parallelograms. What I'm going to do, I'm going to give you the properties of parallelograms that I want you to know. I'll give you some informal proofs of why it is so, and give you a couple problems that may show up on the test as far as how to solve these algebraically. The first property of parallelograms that I would like for you to know is that opposite sides are congruent. In order to do an informal proof, the first thing that I am going to do is I am going to draw a diagonal. Once I have the diagonal, I've broken this into two triangles. Remember, these are parallelograms, and so the top and the bottom therefore must be parallel. Well, that gives me a z, and when I see a z with parallel lines, I automatically think alternate interior angles, and so this angle must be congruent to this angle. But remember also that these two sides are parallel by the definition of parallelograms, and so I also have a z, even though it's turned on its side. I also have this z, and so I have two more alternate interior angles because the lines are parallel. Those two angles are also congruent. And notice that these two triangles share a common side, therefore we know that that common side must be congruent by the reflexive property of congruence. Now, if I look at triangle 1 and triangle 2, I realize that they must be congruent by angle side angle. Because the two triangles are congruent, I know that all of their corresponding parts must be congruent. Corresponding parts of congruent triangles are congruent. If you look at the corresponding parts, you'll find out that the top and the bottom correspond. The left and the right correspond, and so the top and the bottom are congruent, the left and the right are congruent. Opposite sides of a parallelogram are always going to be congruent. Now, what might I ask you algebraically? Well, I could ask this. So maybe this side is 2x plus 5, and this side is 5x minus 7, and ask you to solve for x. Well, opposite sides are congruent. The definition of congruent means that their lengths must be equal to each other. So all I do is say 2x plus 5 is equal to 5x minus 7. One of the things I could do is add 7 to both sides. That would tell me that 2x plus 12 is equal to 5x. Then I could subtract 2x from both sides. That would tell me that 12 is equal to 3x. X is equal to 4. In order to check that, where I see an x, I'm going to put in a 4. If I look at the top, 2 times 4 is 8. 8 plus 5 is 13. On the bottom, 5x minus 7. 5 times 4 is 20. 20 minus 7 is also 13. That means that these two sides are congruent. Their length is 13. Solving for x, though, x was equal to 4. That's the first property. Opposite sides of parallelograms are congruent. Property number 2, consecutive angles are supplementary. Well, if I have a parallelogram, I have two parallel sides again. If I look at this left side is like a transversal. And if I look at angle 1 and angle 2, those two angles are co-interior angles. I sometimes call those same side interior angles. And we know that same side interior angles are supplementary. Consecutive angles are supplementary. How would I solve that algebraically? Well, let's say that this angle is 2x plus 5. Let's say that this angle is 5x minus 7. What would I do to solve? Well, because they're supplementary, supplementary means they sum to 180 degrees. All I'm going to do is I'm going to take these two numbers, 2x plus 5 and 5x minus 7, add them together, and set them equal to 180. Believe it or not, this scribble scrabble I have right here is 180. I'm going to combine like terms. 2x plus 5x is 7x. 5 minus 7 is minus 2. So 7x minus 2 is equal to 180 degrees. Adding 2 to both sides, 7x is equal to 182. Dividing both sides by 7, I believe I'll find out that x is equal to 26. Yes, x is equal to 26. Let's try that just to make sure. 2 times 26 is 52. 52 plus 5 is 57. 5 times 26, that doesn't look good at all, does it? Okay, well, let's try again. Let's find, maybe it is, maybe I just can't add. All right, 130 minus 7. 130 minus 7 is 123. It looks good. Maybe just my math didn't look good for a second. What do I know about 57 and 123? 57 plus 123 is 180 degrees. Sure enough, these two angles are supplementary. My value for x is 26. All right, property number 3, opposite angles are congruent. That also is a real easy proof. Remember, 1 and 2 are same side interior angles, so they are supplementary. 2 and 3 are same side interior angles. They are supplementary. We have a congruent supplements theorem that says if two angles, namely 1 and 3, are supplementary to the same angle, then those two angles must be congruent. And sure enough, angle 1 must be congruent to angle 3, or any opposite angles of a parallelogram are congruent. What would I do to solve algebraically? Exact same thing as I did on the first example. Because they're congruent, the two measures have to be equal to each other. So if I were solving this, I would say 2x plus 5 must be equal to 5x minus 7. And since we solved this once before, I'm not going to do it again. That'll just tell me that x must be equal to 4. Opposite angles are congruent. Property number 4. The diagonals of a parallelogram bisect each other. That's going to be true for any parallelogram that we have, including rhombuses, including rectangles and squares. The diagonals bisect each other. Always going to be true as long as it's a parallelogram. The proof is pretty close to what we've also done before. Remember, because it's a parallelogram, opposite sides are parallel, I start looking for z's. Okay, well, here is a z, and so I know these two angles must be congruent to each other. Okay, I can also do a backward z. These two angles must be congruent to each other. I know opposite sides are congruent, so by angle, side, angle, these two triangles must be congruent. And if you look at the corresponding parts, there are two corresponding parts. There are two corresponding parts. The diagonals are always cut into congruent parts. Well, that's the definition of bisect. A segment bisector cuts another segment into two congruent parts. Once again, algebraically, almost the exact same thing as we just did in the last example. Let's say this piece of the diagonal is 2x plus 5. This part of the diagonal is 5x minus 7. Because diagonals bisect each other, this diagonal must have been bisected. Bisect means cut into two congruent parts. Congruent means you can set them equal to each other. And so 2x plus 5 is equal to 5x minus 7. And once again, x must be equal to 4. Property number 4, diagonals bisect each other. All right, what I want you to do now, I'm going to give you a few practice problems. I want you to look at this problem, pause the recorder, try the problem, and then turn it back on, and I'll solve it with you. So go ahead and pause it now and try this problem. Okay, when you're trying to solve this problem, one of the things you may have noticed that you might have tried to do your opposite angles are congruent. The problem with trying to do that first is this bottom left angle has an x, the top right has a y. You're stuck with two variables and you only have one equation. It's not going to work. But what I do know is that these two angles here are consecutive angles, and consecutive angles are supplementary. Supplementary means add up to or sum to 180 degrees. So I can say 2x plus 7 plus 8x plus 3 is equal to 180 degrees. Combining like terms, 10x plus 10 is equal to 180. 10x therefore must be equal to 170. X must be equal to 17 degrees. Okay, so if x is equal to 17 degrees, 2 times 17, I'm down in this bottom left angle, 2 times 17 is 34. 34 plus 7 is equal to 41. The measure of the bottom angle is 41. So the measure of the top right angle must also be equal to 41. Y minus 6 is equal to 41 degrees. Adding 6 to both sides, y is equal to 47. So x is equal to 17, y is equal to 47. All right, pause recorder and try practice number 2. Okay, here's what we have. We have opposite sides. We know the opposite sides of a parallelogram. And by the way, if I didn't say so before, we're assuming that all the figures that I put up here are parallelograms, even though I didn't put the markings on them. Okay, so let's work this parallelogram. Opposite sides are congruent. The easiest one seems to be solving for x. 6x plus 7 is equal to 8x plus 3. I'm going to subtract 6x from both sides. And then I'm going to subtract 3 from both. Well, let me do this first. 7 is equal to 2x plus 3. Subtracting 3 from both sides, 4 is equal to 2x. So x must be equal to 2. I'm going to check that just to make sure. 6 times 2 is 12. 12 plus 7 is 19. 8 times 2 is 16. 16 plus 3 is 19. And so I'm pretty confident x is equal to 2. Now we need to solve for y. We're going to set these two equal to each other. Y squared is equal to y plus 6. Okay. That looks like a quadratic, so I'm going to put everything on one side, and I'm going to get y squared minus y minus 6 is equal to 0. Now, in order to solve the quadratic, this should factor pretty easily. I'm looking for two numbers that multiply together to give me negative 6 and add together to give me negative 1. Well, the two numbers that multiply to give me AC and add together to give me B, multiply to give me negative 6 and add to give me negative 1, are negative 3 and positive 2. So I can factor this as y minus 3 times y plus 2 is equal to 0. Well, if a product is equal to 0, one or the other factor has to be equal to 0. So either the factor y minus 3 is equal to 0, or the factor y plus 2 is equal to 0. If y minus 3 is equal to 0, y is equal to 3. If y plus 2 is equal to 0, y is equal to negative 2. Now, because it's a quadratic, I need to check my answer not only to make sure I did things correctly, but also for extraneous roots. Let's see if they both work. If I plug in 3 for y, over here 3 squared is 9. Over here 3 plus 6 is 9. 3 is a good answer. What about negative 2? Okay, negative 2 squared, well, to square a number means to multiply it by itself. Negative 2 times negative 2 is positive 4. On the right-hand side, negative 2 plus 6 is also 4. So I actually have two good answers. Y could either be 3 or y could be equal to negative 2. All right, pause the recorder and try practice number 3. Hopefully this wasn't too hard. We know that diagonals bisect each other. Solving for x, I can just set the two numbers equal to each other. 2x plus 3 is equal to 4x minus 1. So adding 1 to both sides, 2x plus 4 is equal to 4x. Subtracting 2x from both sides, 4 is equal to 2x. And dividing through by 2, x is equal to 2. 2 times 2 is 4. 4 plus 3 is 7. 4 times 2 is 8. 8 minus 1 is 7. So x, sure enough, is equal to 2. We can do the same thing for y because the diagonals bisect each other. We can say that y minus 10 is equal to 18 minus y. Adding a y to both sides, we get 2y minus 10 is equal to 18. Adding 10 to both sides, 2y is equal to 28. Dividing through by 2, y is equal to 14. Let's try 14 in here. 2 times 14 is 28. 28 plus 3 is 31. 4 times 14 is 56 minus 1. We certainly did something wrong, did we not? I see what we did wrong. I checked the wrong answer. Let's plug it in the right answer this time. 14 minus 10 is 4. 18 minus 14 is 4. And so when I actually plugging y in for y instead of y in for x, sure enough, y is equal to 14. Okay, hopefully these problems helped you some. We will certainly be trying more in class. Those are the properties of parallelograms.